Hi there, welcome back. I'm Amy Jensen, and today we're going to do a quick review of polynomials. So if you're having trouble and you don't get it, grab a piece of paper and a pencil and let's work some problems together. And so let's start reviewing what it means when we say the degree of a polynomial. So basically, all that you need to do is look at the largest exponent, and that will tell you what the degree is. So for example, if you just have a number, that's really x to the 0 power. There's technically no exponent. And so that's considered a 0-degree polynomial, or what we call a constant. If we take something that's 2x, that's really 2x to the imaginary 1 power, and that would be considered a first-degree polynomial, which is just a line. You know y equals mx plus b, and that would be a linear form. And then the 2x squared would be a second-degree polynomial. And first degree would be linear, second degree would be quadratic, and that would be basically a parabola if you were to graph that. Then the next one would be 2x cubed, so anything to the third power would be a third-degree polynomial, which is what we call a cubic function. And then something times x to the fourth would be a fourth degree, which is what we call a quartic, and so on. So the important thing is, when you're given a problem, you want to remember to put all of your terms in the right order, and that order has to be from left to right, starting with the highest exponent. So you want your exponents to go in descending exponential order. So let's take this example. Obviously, the exponents and the terms are out of order, so we need to put that 7x cubed in the front. And then we'll go with the next one, which should be the x squared terms, so 4x squared, followed by the 3x, and then the constant 3. And this, of course, would be a third-degree polynomial, or what we call a cubic. So let's go over just some practice problems and operations with polynomials. So basically, there's three types of problems that we might see. We might be asked to add and subtract. And really, you just really want to think about that as combining like terms. The second would be to multiply, and the third would be to divide. So we're going to cover divide in a different video. But for today, I'll go through several problems where we add and subtract, and then where we multiply. So remember, add and subtract, we're basically just combining like terms. So let's look at an example. So if we take this simple example, 4x plus 5, plus 3x minus 2. We just want to combine the terms that just have the single x. 4x plus 3x gives us 7x. And then, of course, 5 minus 2 would give us 3. And you want to use the sign that goes with the larger number, obviously, when you're combining your like terms. So how about a second example? Okay, so here's just another example, and we want to, first of all, I tend to start with the largest exponent so I get it all in the right order from the get-go. So we have our 5x cubed, and now I'm going to combine my squared terms. So 3x squared minus 6x will give us minus or negative 3x squared. And then I just have one term with an x in it, 4x. And then we'll combine our constant numbers. So we want to make sure that our final answer is in the right order. So we always need to put our final answer in descending exponential order, which is why I tend to start with that highest exponent first. Okay, so we'll get a little bit more complicated. So we have 2x plus 2 minus, and we'll do the minus the quantity of 4x squared plus 5x minus 6. So remember, when you see this parentheses after a minus sign, you need to distribute that negative. So I just go ahead and I start by changing the signs for all the terms in the parentheses. And then I'm going to combine my like terms. So now we have our 2x minus 5x gives us negative 3x. 2 plus 6 is 8. And again, if you start with the largest exponent first, then your answer will always be in the right order. Okay, so the biggest mistake students make here is forgetting to distribute that negative sign to all three terms within the parentheses. Okay, you want to be careful though, because you might have a problem like this. We have a little bit more information here. Okay, so now my x cubed minus 5 at the end there, that is not in the parentheses. So when I distribute the negative, I only distribute it to the three terms that are inside the parentheses. And then I'll just rewrite these here. And then I start combining my like terms, start with my x cubed, and then I'll do my squareds. So 2x minus 5x squared, I get negative 3x squared. And then 6x plus 1x, remember there's an imaginary 1 in front of that x, and then I have my two numbers, minus 12. And just check, make sure it's in the right order. Looks like we're good to go. Okay, so a lot of times you'll have a word problem, which we call a real world example or an application problem. So let's pretend we have a little puppy, Fido, and we want to build a fence around our yard. So we have a fenced yard that's in the shape of a rectangle. The length is 10 feet longer than the width. Okay, so some of these key words like longer than, longer just means add. Don't multiply the width times 10. So I have the width, I'm just going to call x. And then the length will be 10 times more, so x plus 10. And I can go ahead, since it's a rectangle, I can add the width on both sides would be the same, and the length would be the same. And then the question we might be given is write a polynomial expression to represent the perimeter of the fence. So the perimeter, remember, is the distance around the outside. So we just want to start at one point, it doesn't really matter where, and just add up all of our terms. And then we're going to write an expression for the perimeter. So we have x plus 10 plus another x plus that last length, x plus 10, and we just combine our like terms. So technically, if it says write an expression, you don't need the perimeter is equal to our answer. But if it were to say write an equation, you always have to have the equal sign when you write an equation. Okay, so let's move on and let's do some problem with multiplying polynomials. So we'll start with some pretty simple problems, such as just taking a constant, such as a number, and multiplying that by, say, a binomial. So a binomial is a set of two terms. So let's say 2 times the quantity x plus 4. So remember, whenever you see those parentheses, you have to distribute that 2 and multiply it to both terms. So we'll get 2x plus 2 times 4 is 8. And that's all we can do. It's in the correct order. No need to reorganize. Easy peasy. So let's try a little bit harder example. So again, we have a constant 3x, but we're going to multiply that times our binomial. Sometimes people get confused when you have a variable like x, but x times x, remember we have that imaginary 1 there. When you multiply variables, you add the exponents. So we get 3x squared plus 11x after we distribute. So let's try a little bit harder one. So now we have multiple terms. That's actually a trinomial that we're multiplying by 3x. It's out of order, but nonetheless a trinomial. So we're going to multiply 3x, in this case, times 2x squared. Again, remember you add the exponents. We get 6x cubed plus 21x. And then now it is not in the right order. We need to put this in descending exponential order. So always take a minute and pause and make sure that your final answer is in the right order. So let's put that 6x cubed at the front, followed by 3x squared plus 21x. Okay, so moving on, we'll do some more examples here. So how about a binomial times a binomial? So that's when we have these set of two terms, each in parentheses, and you'll remember the acronym FOIL. FOIL stands for first, and then we multiply the outside, then the inside, and then the last. And of course we combine those two middle terms because they're both just x's. So we'll have 4x plus 3x, that will turn into 7x. So we get x squared plus 7x plus 12. So always check your order. Sometimes they'll give you the wrong order just to confuse you. So check it at the end just to be sure. For example, in this case, because the second binomial is a different order, we're going to have to do some rearranging. So we did the first and the outside, now the inside, and the last. So again, now we need to rearrange the terms and combine our x squared terms. So we'll start with our x cubed, the largest exponent, and then we'll combine our 2x squared plus 4x squared gives us 6x squared, followed by our 8x. And there we have it. So here we go with another example. Okay, these get confusing because we have the number on the outside. So you want to start here on with the terms that are inside the parentheses. So we're going to FOIL that out and do that first. Remember your PEMDAS. Please excuse my dear Aunt Sally, order of operations. So now we get x squared plus 5x plus 6. And now don't forget that 4. We need to distribute that 4 to all three terms. So we get 4x squared plus 20x plus 24. Okay, here we go with the next problem. Okay, so similar problem, we just have a variable out front. So again, you want to start with the inside. Now we're going to FOIL that out, get our trinomial. And in this case, we don't have like terms to combine because we had an x squared versus an x in the original two binomials. So nonetheless, I'm going to distribute that 2x to all four terms now. And make sure it's in the correct order of descending exponents, which it is. So let's see if I can give you a little bit of a challenging one. We'll put a red star here because you might want to go back to this once you feel pretty good about it. So these are the ones that really confuse people. So we have a binomial times a trinomial, and people get all stressed out, but don't get all stressed out. We can do it. So one technique to do is make yourself a little box, and we'll make a little matrix here. And so write the first binomial terms on the left, and I'm going to write each term from the trinomial across the top. And we'll make our little boxes, and I'm going to multiply each of the terms together. So x times x squared, I get x cubed, x times 4x, 4x squared, x times negative 6, negative 6x, and then we'll repeat the same with the bottom row. So 2 times x squared, 2 times 4x, and then 2 times negative 6. And now I do what I always do, and I just combine my like terms. So I'm going to start with my x cubed, because that's the largest exponent. And then I have 2 terms that have x squared in them. So I'm going to combine those. And I'm going to get 6x squared. Then I have 2 terms with just an x. So 8 minus 6 is 2, so 2x. And then minus 12. So these look really challenging, but if you just take a minute and make yourself a little matrix, they're really pretty doable. And again, we'll just go back and make sure we have everything in descending exponential order. And looks good. Okay, so let's try a real world example with multiplying polynomials. And actually, you'll find this occurs all the time in the real world. So let's go back to our dog Fido again. And we're building a fence in the backyard. And now we've decided, special little Fido, we want to put AstroTurf grass in the fenced yard. And so we need to figure out the area. So remember, area of a rectangle, you multiply length times width. So if the length of the yard is 5 feet more than twice the width, how much grass do I need? And we need in square feet. So square feet implies that it's area. So in this case, again, we'll call it the width x. And this is kind of confusing. It says the length is 5 feet more than twice the width. So twice the width, 2x plus 5. So more means you're going to add that amount to it. So 2x plus 5. So again, with my area, I'm talking about the inside amount of square footage that we need. So I just need to multiply the length times the width. Or in this case, I usually do the width, because that's just the x, times the length. So let's go ahead and do that. And again, we need to distribute the x and multiply x times 2x, and then the x times 5. And so we end up with an expression, or an equation actually, that the area is equal to 2x squared plus 10x feet. So we just went over a lot very quickly. So if you're confused, go back and re-watch parts of the video and pause it to rework the problems. Remember, with practice, you can do it. Hopefully you feel better about working with polynomials. Thanks, and we'll see you next time.